Greetings from my recording studio in beautiful downtown Kathmandu, Nepal. In this video, we'll leverage what we've learned about the square quadratic equation to solve a rectangular quadratic equation. But first, let's do a little review and contrast. In this slide, on the left-hand side, the graph represents the area of a square quadratic equation, and the graph on the right-hand side represents the area of a rectangular quadratic equation. The primary difference here is that for the square quadratic equation, the vertex right here, the vertex will always lie on the x-axis, and for the rectangular quadratic equation, the vertex can lie either below the x-axis as it does here, or in some cases can lie above the x-axis. Continuing in our comparison and contrasting, on the left-hand side, all this information pertains to the square quadratic equation, while all the information on the right-hand side pertains to the rectangular quadratic equation. So starting with the square, the first item, the constant term, in this case 9, is always positive because it is the square of this number right here in the binomials. For a square, this number and this number will always be the same, so you're squaring it even though it's negative, and a negative squared is still positive. This constant term will always be positive whenever you have a squared quadratic equation. The rectangular quadratic equation, on the other hand, the constant term, which is minus 16 in this case, can either be positive or negative. Back to the square, the product of x plus 3 times x plus 3 can be written as x plus 3 squared. That's very important for us when solving quadratic equations. We'll see it in a little while that's the case. In contrast, the product of the sides of a rectangle cannot be written as a square. On the left-hand side again, x plus 3 squared is easy to solve for x because all you have to do is to take the square root of both sides of an equation that has this term in it. That reduces that to a linear equation, which you have lots of experience solving. In a rectangular quadratic equation, the product of the two binomials is not a square and is not so easy to solve for the x, but we have techniques for that. And finally, and very critical to us whenever we're trying to complete the square, is that this constant term in a square quadratic equation is always half of the middle term divided by 2, and that number squared. So 6 divided by 2 is 3, and 3 squared gives us 9. That's always true for a square quadratic equation. And that's definitely not the case for a rectangular equation. Now for a massively major new concept. And that concept is simply any positive number can be written as a perfect square, add or subtract some amount. This is one of the great secrets for solving a rectangular quadratic equation. We'll see soon why that's the case. But let's go ahead and look at this concept in a couple of different ways before we move into using it in an equation. Here's the first way of looking at it. I have this table of numbers. The left-hand column of that table are just the numbers 1 through 10, while the numbers in the right-hand column are the squares of each of these numbers in the left-hand column. So 4 times 4, 4 squared is 16. 7 times 7 is 49. 9 times 9 is 81. So what I've said is that we can represent this number 56 by taking one of these squares and then subtracting or adding to that square to get 56. For instance, 9 times 9 is 81. And if we subtract 25 from 81, we get 56. Likewise, if we take 49, which is less than 56, we're going to have to add something to it. So here's my perfect square. I'm going to have to add 7 to get to 56. The second way to look at this is to draw a large square whose area is 81. And inside that square, we have a rectangle whose area is 56. This just represents the fact that this blue area here represents the amount of area that we have to subtract to take this large square down to this rectangle. And just like on the previous slide, that number is 25. So we have to subtract 25 from 81 to get that 56. Now with all of that done, it's about time for us to see what it looks like in an equation. I brought that square and the rectangle forward so we can reference it easily. We were given early on that the rectangle has sides x subtract 2 and x add 8, and we said that that equals 56. That's this 56 right here. Typically you won't be given the quadratic equation in this form, but more in this form here. And that's to solve for x. That's what we mean by solving the rectangular equation, is getting the values of x that make that a true statement. In our earlier treatment of the square quadratic equation, we were given two terms like x squared plus 6x, and we were requested to complete the square. Whenever I'm saying complete the square, we're looking for this large area here. That's the square that we're trying to complete. And remember, to get this constant right here, we always divide this middle term, the x term, by 2. 6 divided by 2 is 3, and we square that to get this number right here. Now, if we just added 9 to that side of the equation, it would change the value of the left-hand side of the equation. So we need to zero that guy out. So we added 9, we subtract 9, and the sum of these two terms is 0. So we just added 0 to the left-hand side of that equation. And here's that minus 16 that's still there. So now we do a little bit of arithmetic. This is my complete square, and that complete square is this 81 up here. There's that minus 25 that we said we had to subtract from 81 to get 56. So we're in pretty good shape so far. Let's move on. So we're here at this point. This is the perfect square. We're going to add 25 to both sides to get rid of this negative 25 here. And we do that, we get x squared plus 6x plus 9 equals 81. Once again, that is this big square up here. That's the square that we completed. Now we're going to write this perfect square in terms of squared binomials. That's going to be x, add 3 to quantity squared, equals 81. And this is where it gets really easy for us to solve for this rectangular equation. Once we take the square root of both sides, we get x plus 3 over here. We reduce the order of this equation from a square to a linear equation. On the right-hand side, we took the square root of 81, and you'll recall that the square root of 81 is either plus 9 or negative 9. If I square positive 9, I multiply it by itself, I get 81. If I square negative 9, that's negative 9 times negative 9. A negative times a negative is positive. That is positive 81 again. And then we just subtract 3 from both sides. And you'll recognize this as the vertex plus a distance from the vertex. And we add those two numbers and we get 6. In the second equation, we get x equals negative 3, subtract 9, and that equals negative 12. Remember that you'll always get two equations, two answers for a parabola, and that is because the parabola does this, and you're looking for a value, in this case 56, and you read across to the parabola. There's going to be two places it crosses the parabola, and there's where you get your answers. Let's move on to the graph. So whenever we did the calculations earlier, we said that x equals 6, and we said that x equals negative 12. So if we drop down from 56, that's the area of the rectangle that we were looking for, and we just follow that vertically down to the x-axis. There's my x equals 6, and we just drop this one all the way down to the x-axis. There's my negative 12. So this is the way we can check our work, right? If you graph the equation, that will always give you a really good check on whether you did the work correctly or not. So hopefully you have that in good shape now. If it was a little confusing, go back and step through it slowly. Look at every step that we did. We'll be using this a lot in the 9th grade. I mean a lot. So if you feel confident, or when you get to the point you feel confident in your ability to handle that, then I gave you this one here to do. It's going to be x squared plus 6x plus 16 instead of negative 16 equals 56. And in this case, if you do everything right, you'll see that this is a small square plus something to give 56. Go ahead and work through that. Maybe even pause the video, maybe even stop the video, and when you come back, you can check your answers with this graph. One thing I'd like you to notice in this case is that the vertex lies above the x-axis. The rectangular quadratic equation that we did previously lied below. So there's that statement that that vertex can lie above or below the x-axis. Thank you for listening. And here at the end of the day, there's only one thing left to say, and that is That's all, folks. Folks. Guys, be safe. Con cuidado.